Alright, we have another Enesco. This one is Mickey's Mountain Patrol. Says to plays the tune Winter Wonderland. On these Enescos, I'm not doing so well as far as fixing them, because finding some of the parts are getting to be hard. At the moment, I'm one per. This will be number 4. So, one of them is almost repaired. It's just, I'm waiting to try and find a motor. Once I find a motor, we're good. And another one, I can't get a part at the moment. So, this has the instruction manual. Transformer is a 9-volt, 400 milliamp, 4 to 500 milliamp again. That's one of the variables. 120 volts in. It says that there's the operating switch is on the back next to the transformer jack, and that the cable cars use a rubber band to move the seats. We got the title card that folds, and then you can set it up in front with the retail price. So that would be the display for the store. Of course, we have the I want to know everything about you, your age, race, sex, and income, the standard thing that businesses want the old days before they just started hacking your phone for it. And now we have just the advertisement of different music boxes. So most everything is still there. Here is the power supply. Set it off to the side. It's just an empty bag. And there is Mickey. And this has a date on the inside of the lid. I don't know if you can read it, but it says 27 June 1995. So it's another old piece. It's having some issues. And there's nothing in the back of the phone. So let's put this back in the box and get this off my bench so we can take a look at it. There we go. There we go. Box is out of the way. And there it is from above. Here it is from the sides. We have the Enesco medallion plastic, a little card that says, caution, due to the complicated design of this product, it's recommended to operate at upright position on a stable surface. Do not to attempt to manually operate any of the moving parts to avoid damage. So let's see, we got Goofy and Pluto, Donald and Mickey. Here's Donald coming through the underside there, and then a mouse snowman. So those are the 5 characters that are attached. And then over here we have the belts, and here is Minnie Mouse. And the belts have little hooks on the end for the hooks of the chairs. So it comes with a spare belt because there's only room for one. These are probably pretty impossible to find, I would assume. It's an O-ring with a set of little loops on it. There we go. And there's only 2 chairs in here. So, and I'm assuming Minnie was stuck right here because you can see the glue, and the glue on her butt is broke free. So she sat right there. So we're going to put her in the bag so we don't lose her or damage her. I'm going to set it off to the side. Probably glue it back on before we ship it back. That bag. Alright, let's make sure. 9-volt, 500 milliamp. So this is the right adapter. Plug it in. Everything's moving, but it does have a clicking, clunking sound. Goofy's moving back and forth. We got Donald going around the bottom. We have the snowball behind him rotating that he's looking at with his side eye. Mickey's moving back and forth, scanning the horizon with something attached to a scope. We got the radar spinning, and of course we have the ski lift rotating in a circle. I don't know if you can hear the clunking sound. The music plays fine though. Let's turn that off before we all go insane trying to listen to it. So let me see if that was the main issue, is the clunking. It's going to take me just a second here. Somewhere I have a list of what is wrong with these different Enesco pieces. Let's see. Oh, it's weird. I can't find the reason that this one's here. It's probably just missing it. So since everything is functional, I'm going to go with the fact that it's clicking. Since I currently can't find the description on this one, I might be able to find it later. I don't want to spend the next half an hour looking. On the bottom it says this thing was actually built June 27, 1995. Forgot what the box said. It's out of the area now. This is made in China exclusively for Enesco, and of course it is the Winter Wonderland. Let's power. And I am going to pull the belt off so we don't lose the chairs and or the belt. This is the drive motor. This is the idler. So all the mechanism runs across and runs up here. Of course, this plastic here that's painted like wood is to manipulate him. The mouse snowman is solid, and I'm sure there is a metal shaft that runs up in here to drive this pulley. The clicking sound most likely is a broken gear, or a chipped gear, which would still technically be broken, and it's causing it to do the clack. On the bottom here, there is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 outer screws and 3 screws in the center. If this is like the other Enescos, these 3 screws are only holding in the music box, and the screws around the outer edge are actually what holds the bass on. I'm just checking to make sure I can set it on its back without any small pieces like this snapping off. As again, my goal is not to break it more than they already are. Nope, that's too big. Nope. I think this one's going to be too small. Put that one. So let's get these outer ones out and see if we can get a look at the inside and see what's going on with the clacking. Okay, 2 more screws, and hopefully we'll have this apart. There we go. All right, now we'll see if it's actually like I said, where it's the music box is still attached. Yes. So those 3 screws just hold on the music box, just like I thought. We have a circuit board with a trim potentiometer right here. That's probably the trim for the speed at which everything is rotating. Since there is no speaker, we're using the music box assembly. I thought that was a break. I'm going to flip it up and show you the mechanism in just a moment. Basic circuit board. The power comes in off of this red wire right here. It's distributed through the board. This black wire is the ground to return. And we have the trim pot, a transistor, 3 diodes, 2 resistors, and I'm going to assume that's a voltage regulator. I don't know. I don't see any numbers on it. On the side pointing down. Anyhow, there's this green wire and this white wire go up to a motor that's right here. And again, I'm going to tip this up so you can see it better in just a moment. And then this red and black wire go to the motor right here, of course. You can see that, which drives the music box. Which these fine little gears appear to be in good shape for the age. You don't see any stress fractures on the edge. Nothing on the worm gear. Nope. I'm going to turn it on real fast and see if I can find that clacking sound a little bit better, and then we'll tip it up. It's probably going to get a lot louder since the music box is now exposed. Clacking is coming from up here. Well, I can see one gear has a fracture in the nose. I can't tell about the teeth. So we're going to turn it off since it says you shouldn't run it on its side for long periods of time. Glitter everywhere. So here is the mechanism in the bottom. The motor is right here, which drives a pulley set that's right in here, which then drives this big gear, and there's a shaft that comes down off of one of the planetary gears that runs this gear, which then it has drive shafts with worm gears that spin, which makes goofy move. This is the steel shaft I was telling you about that spins this wheel up here, and then this set of gears right here rotates Donald on the disc. This gear that's right here has a crack right on the front, but the teeth look fine. But this grease is really nasty. It's really brown. The grease over here is still clear. This has been picking up a lot of dirt and debris over time, most likely because it's next to the sound hole, since there's no speaker. And it's probably just dust that's been ingressing into it, and of course these are the primary gears right here in this area, and that's probably why this is all gummy while these are all clear. So appears to get into this section, we're going to have to remove some screws on the drive shafts. Right here, here, and here. Here, 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 here. This screw is missing, and I didn't see it fall out when I took it apart. So either there's a mistake, or it's been taken apart once before and I didn't put a screw in. Or the screw fell out and it's stuck somewhere inside the mechanisms, which I don't see. Gravity would indicate it'd be down in here underneath, but yeah. The way these drive shafts are mounted, You don't have to take all the screws out. You only have to take out one on each side and then pivot this block, which allows the drive shaft to come out. So I just pivot them down, and then I can pull out the drive shaft. Pivot it out of the way, pivot this one out of the way, and then pull out the drive shaft. Alright, we're going to inspect the worm gears. This one we're going to have to clean off this brown grease so we can see inside. If I have a screw that fits, I'll replace the screw that's missing. It's not a super high torque thing, but it's still nice to have everything the way it's supposed to be. Okay, those look good, and they don't spin freely from each other. This one got a lot of grease in it. There we go. That's better. That one looks good. That one looks good. They're still tight. They don't spin freely. Now that I've disconnected these, I'm going to turn it back on, plug it in and turn it on. What I'm going to do is, by removing the drive shaft, if it's still making the clunking sound, then I know it's the next gear cluster. It's just a process of elimination. I'm going to assume it's the gear cluster that spins Donald. The reason I say that is the one gear does have a crack in the front, but I can't see anything on the teeth. Still clunking. So, this next section, the big red housing with the motor, whew, it's got a stack of screws everywhere. What is going to be the best plan of attack on this guy? Looks like I'm going to have to separate the center layer to get to the top layer. The bottom layer can stay attached because it has holes for the screwdriver to get into the second layer and unscrew the second layer from the top layer. It's like a 3-layer sandwich. So let's try that. I'm assuming they put these notches and holes in here for that reason. And let's see if my assumption is correct. Screw. Oh, just one screw. Oh, 2 screws. If you're taking apart your animated stuff, take pictures if you're not sure if you know how to put it back together. And look at it. Look at how it's built before you just tear into it. And usually you can find ways to disassemble what you need without disassembling the stuff you don't need, which just causes more grief. Also, try not to smack it, like me. Alright, that is the drive gear that goes up to the base that spins Donald. That's the drive assembly. The gears that are in the center here, which I'll try and tip up in just a moment again, they're the ones that make the snowball turn. Alright, clean off that grease, check out the teeth. All the teeth are there, no fractures, and the gears are still tight on the shaft. And like I said, this is the one that has a crack, and I'm thinking this is the one just making all the noise. The other end of it is right here, and also it wobbles, which could be the slack because of the crack. And then that, of course, this gear drove that one I just removed. It's got a nice chunky gear here in the middle. I don't know if you can see that, how thick it is compared to the rest of them. And then inside we have a 1, 2, 3, 4, 5 cluster off of this pulley. This pulley goes across, goes down, and drives 5 gears, and one of them is that notorious 10-tooth, which always breaks. And all this grease is just nasty. So let's turn it on again for a moment. Nothing animatronic is going to move, so there's going to be no risk of damage to anything up on the top piece. All the animatronics are controlled right here, and let's see if it's still clicking. It is. It's just not as loud. I'm going to say it's a combination of this gear and probably that 10-tooth is broke. But as I promised, let me show you the gears that are in here so you can see what I'm looking at. So there is the 2 planetary gears. You can see this one's at an angle, maybe. Might be hard to tell. It's not square. That's what's turning the snowball. This big gear right there is what turns Donald. Here's Goofy, his gear, and here's the pulley for Minnie right there. And you can see the, we'll just call it chocolate pudding, all across the back there. There's a few other names for it, but we're not going to refer to it as that. So this is still clacking. It's not as loud because it's not attached to anything, and my fingers are absorbing the clicking vibration. In my fingers it goes clack, 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 clack. So we'll tear into this further. Since 90 some odd % of these things, whether they're Enesco or Limax, it's always the 10 or 8 tooth that breaks. And unfortunately, because it's brown from the grease, I can't tell you if it is or isn't broken at the moment. So we're going to have to take this sandwich apart, which is 1, 2, 3, 4 screws. Now the motor wires, which are soldered to that circuit board, and they're also soldered to the back of the motor, right there and right there, the motor is going to have to, I'm going to have to slide this plate down unless I want to desolder or cut the wires and then repair them. I'm going to try not to do that. So I'm going to just try and slide the plate over the 2 wires. The motor, this motor here, is an FF130SH. In case you all want to replace the motor, if you have this piece or something similar. It is a hobby motor. There's plenty of them out there. I don't think they make the exact same FF one, but they have something similar. F-series motors seem to be pretty common on a lot of these. And then this one doesn't have a marking where it's on the bottom side. But this is a shouldered little guy. Most motors that have shoulders are really hard to find right now. So you know what I'm talking about. It's an unshouldered motor. As you can tell, it's just a cylindrical body with a little nose sticking out. And you can see this one has the shoulder up here. This is from another Enesco and Department 56. It's slightly bigger, but they like to use these shoulder motors. And the ones that have those step-down shoulders, they're actually pretty hard to find in the correct diameter. So, all right, the 4 screws are out. The only thing holding it is the tension of the pressing of the gear, which would be this big gear here. Because this gear is pressed to this gear on this side too. So one of these 2 gears slides off. I just got to figure out which end it is. And for that, I'm going to try and use a spudger. If I can remember where I put it. Right there. Okay, that side's not moving. And that side's not moving. Unless that's why this gear is so fat, that they press it into both sides. Nope. do I got to try and put tension on this? Not what this tool's for, but I'm going to see if grabbing the outside edges. This tool is for removing computer chips from boards. And no, I don't want to damage the teeth. I might have to take a moment break while I figure out how to separate this bad boy. See if this will do. All I'm doing is flexing the plastic a lot. Let's see if it separates here. Nope. Alright, let's try this side. Guess we'll try it this way. Wonder if they glued it. Now, real fast, when I was telling you about, if you unscrew one side, you can pivot it, pull out the drive shaft, and just push it back so it's out of your way. So you don't have to worry about losing the additional screws. The belt looks good. Got some glitter on it. Well, I think it is the 10 tooth. It looks like it is cracked. I need something small to get in there. Yes, this little gear right here, which is the standard 10 tooth, is split right there. Because when I rotate it, it gets stiff, jumps the gap, and then starts spinning easy again. That's the clacking sound. Which means that the tension on this has been reduced, and then it's probably not spinning all the time, which means this whole mechanism will intermittently just stop rotating. So, we need to get in here, and the only thing holding this together is this gear cluster. So we need to figure out how to get this gear cluster off without breaking any of the gears, because I'm not sure where to get them all. And I know where to get the 10 tooth. I got lots of them. Matter of fact, there's one right there. So we'll get it off, inspect this one that has a cracked nose, and replace that 10 tooth. Now the question is, how do we get this bad boy apart again? Oh, well, the shaft sticks out right here on this side. This side it's just below flush. I'm wondering if the shaft has been walking, because I don't see a boss this fits into. Like this shaft would fit into something like that on the other side. So I'm wondering if I have to beat the shaft all the way through. You can't really tell, but off camera my bench has a couple of holes on the ends because I used to have things mounted to it at different points. I am going to put this shaft where it's sticking out in one of the holes, or maybe I'll just use a pair of pliers, something that I can do it on camera so you can see. If I can find something. Whole point so you can see what I'm doing. Now, let's try this. I'm going to try and put the shaft that's sticking out in one of these holes. Probably this one, the one that says loop. Like that. That way it elevates it, and I'm going to use this as a drift pin. This is another axle for gears. It fits inside. So now I just need a smacky thing. Smacky thing is a generic term for anything that smacks it other than a hammer. So, something with a little bit of weight. Alright, this isn't working. It's smaller. I hate to do it with my screwdriver, but it fits better in the hole. Okay. Not liking being defeated by a piece of plastic, I'll tell you that. This is a narrower screwdriver. It's a cheaper one too, so if I break it I won't be near as upset. This stuff just does not want to move. It's got a slight wobble to it, and the tip's flat now. One more time. I am not getting any movement out of this shaft. I'm assuming they're knurled, so the gears don't spin freely on the shaft. So one of them has to give, but I want it to slide off and not break off. Also, these little guys here have to come off too. Nothing wants to come off. And the problem is this thing's so old I don't want to break it. It's from the 90s. You'd think with this one having a crack on the tip, it would slide off easier because there's less tension on the knurled section. Apparently that's what we get for thinking. close one. I'm gonna stab myself. Alright. See all that wonderful brown grease. We'll put some clear lithium grease or white lithium grease in here when we're done. It's just how long it's going to take to get this thing done. This gear I'm pretty sure I don't have based on its teeth spacing. So I'll probably end up doing what I normally do, which is sand or cut out the groove and then fill it with some basically super glue and let it harden. Because the teeth are kind of an odd size. The gears down here are standard teeth, but these have the bigger gap teeth. And I've not been successful in finding a lot of them with these bigger gaps. So far. Doesn't mean I won't come across them eventually. So. Alrighty, well, probably take a break while I figure out how to get this thing apart. You're not watching me for God knows how long trying to get these gears off. But the gear here, completely fine. The little gear here that moves goofy is fine. And the two gears here, they're good. And of course the big one's good. Alrighty, well, we're going to pause for a minute while I figure out how to get this gear cluster apart. 4 screws and a pressed on gear. So we'll return. That way you're not watching again for half an hour or however long it takes. And I'm going to see if I can find my gear spudger, which is designed for popping gears and pulleys, and see if that helps. So, shall return. Alright, I finally got it off. Took a little bit of time, but I ended up using thin, long needle nose to get it to start to move, and then the 45s to finish prime up from the center, not the flat edge where you can snap this. And it slid off the top. I expected to come out the bottom, but you don't always get what you expect. That allows me to open this up, as you can see, and get in here to the gears. So this one is the first gear. And here's your second gear. And that's where it's cracked. That one right there, which actually is one gear. I thought it was two. This is the 2 gear. This is 2 gears that are back to back that are pressed on. These gears look good. They're just covered in some nasty grease. Speaking of that, let's get them cleaned off so we can replace it with some new grease. That. And then here is, I believe, the other 10 tooth, and I believe this one is also cracked. Yeah, it's cracked. That's why it slid off so easy once I got underneath it. So, if you've seen all my other videos, or most of them, you'll be able to see the crack. I'm going to try and stick it there. You should be able to see the crack right there. Very, very common, unfortunately. And let's look at this one. This one has also got a small fracture, but it might be repairable with just some glue if I don't have the right gear. Yeah, it's still holding tight, so I should be able to clean that one and then glue it. this baggie of 10-tooth gears. I did find the original email on what was wrong with this, and it was that it wasn't spinning, which is probably because this 10-tooth was spinning on the shaft, which prevents everything else from rotating, but it was making noise. So, yep, same gear, same diameter, and it's got the same hole size. Now this shaft with the pulley does have knurling, and the gears do not have any marks on the inside, so it has to be pressed on. And let's find... trying to keep the pulley as flat as possible, which it wobbles even though the plate isn't flat, the pulley is, so I can get that to start. And then once I get it flush with the metal, I'm going to use the hole in the wire strippers that says loop to try and push it down. This allows the shaft to come up through the hole and me to push this onto the knurled section, like so. And there we go. So if you have a set of wire strippers / wire cutters, a lot of them have this hole right there that says loop. You can try and use these holes too, or get the teeth, but the reason I use this is it's flat metal and you can put equal pressure on both sides. Small sockets do the same thing. If you have a small socket, you can push it on. I just found for the small gears with these small, usually between 1 and 3 millimeter diameter shafts, that I can just use that tool, not for its intended purpose, but you know what? It works. And I own it. I don't have to go buy it. Alright, let's take a look at this crack. Let's get the crack gear out of here. We don't need it anymore. You see if I have a similar gear. It's similar, but I think it's too small. Yeah, it's too small. That one's close, but the nose, the outer gear is basically the same, but this inner nose is smaller and is only 8 teeth. So another close one. There is another way to fix it. Here's another one. Let's try this. Perfect. And perfect. So I do have the right gear. The other way to fix this is you would take this and carefully cut this nose off. Saw, you can work at it with a pair of snips without breaking the big flat gear. Then you press the 10-tooth onto the knurled section sticking up. And if you want to ensure good cohesion, you can put a drop of super glue, but you on the face of the big gear and sandwich them together. I have done it a couple of times, but if you have the right gear lying around in a pile of miscellaneous gears, just do it that way. If not, there are other ways to do it. Like I said, cut off the front and then just glue another one of those gears on it and push it over the shaft. Sometimes you just got to do what you got to do to make it work, and it's still going to function just like it normally would. It's just a 2-piece gear versus a single piece. So let's get all these gears back in their baggie, and then let's reassemble this with some new grease. I'm going to do similar. I'm going to put the loop through. Let's try and get it on camera here, and then push it off. And then that separates it from the knurled section. Not all of it, but there we go. So, and here's this one. See if it'll focus. Use the back of the hand. You can see there's the crack. Big gear's not cracked, just a small nose. And so there we go. Oh, this one might be cracked too now that I'm getting all that black, brown, whatever colored grease off of it. Let's see. Yeah. It's cracked. So, another one to fix. Alright, I guess I shouldn't have done put that bag away so quick, as I need to find another new gear. Slides right off. There we go. All right, let's try and put this back together. I know all the gears aren't in it. What I'm doing is, I don't remember where all the gears technically went. They didn't do the thing I tell you always to do, which is take a picture. Oh, that slipped my mind. Okay, so we know this one goes here. And I believe this one probably went here. So, and I believe this one went. There we go. And those all touch. Perfect. So we got the gears in the right spot. The reason I'm taking it back apart is you notice how the gear fell right off of the shaft, and that one falls right off. It's because this shaft is slightly smaller than the hole, and these shafts can sink below the height, which means that the gears can fall out. So to prevent that, once I put the gear on, I'm going to put a dab of super glue or crazy glue, very small amount, just enough to hold the gear centered. The other option I have is to put a little bit on the shaft and then stick the shaft in the hole and then hold it up, which is probably what I'll do, so in case the gear breaks again, it's not glued on. I know I mentioned in the past, but I prefer the ones with the brushes. Gives you a little bit more control. So. Of course, it's going to have to sit for a moment while the super glue, hardens. There we go. They're both hard now. Hard enough that I can assemble it. Luckily, it wasn't hard enough not to take it apart since I stuck it in the wrong hole. Alright, there we go. Okay. Go. And snap it together. And one of the motor wires broke off, so we're gonna have to solder it back on. It's pretty standard, especially after moving it a couple of times. So I'll heat up the soldering iron and get the green wire soldered back on. Gears roll and are not glued together. Go. Easily fixed. So now it's just a whole bunch of screwing everything back into place. You can see the new gears are all in. Pulley. This wire still looks good. Board's still good. We know that works perfect. Oh, forgot the grease. Easily fixed. Get out a little packet of grease. This is just generic grease. It's similar to Vaseline in consistency. It's a white lithium grease. It is conductive, so it's not something you'd want to use across electrical contacts. You can use it to stop water ingress and corrosion, but you don't want it to span contacts because it will conduct electricity. So I'm just going to put some dabs on here, and then when it turns on, it'll get into the teeth. But before I do any of that, I want to make sure that motor solder wire joints are good and all that, to make sure that you don't have to take it back apart. Stay shut. It's spinning. There we go. But we're having a small issue with it. One of the gears. Yeah, I just broke the white wire. That's kind of odd. That light's vibrating. See if this fixes it. Apparently the tolerance is a hair off. The gear is skipping teeth. That's why we test things, because, well, you never know. Go together. There we go. I'm purposely just taking the wire off. I know the green wire goes on the outside, the white wire goes on the inside. Because having a tolerance issue. Apparently these new gears, even though they look to be the same, are slightly off. Might actually have to fix the old ones instead. Yeah, see, it all blends perfectly there. It's only when I snap it on to the bottom with the drive gear that we have issues. Let's try it one more time and just see if it's just an alignment issue with the motor. There, now it's working. Yeah, it's probably just an alignment issue. When I soldered this wire, it distorted the plastic. I think that's my problem because everything is meshing now. Ooh. That's just 3 volts. You can see the gears are spinning. Everything's spinning, everything's meshed back up. So, if you do this, you have a piece like this, where you have to take it apart. You know what? I'm just gonna move these off the table again. Check the tolerance of your gears. Apparently the one gear was just a sliver shorter than the original gear, this one. And that sliver was causing it to walk out of alignment. So, I found another gear, which, well, it wasn't that sliver, and you can see it's working. And then if you have to solder the wires, you can pull it apart and solder them, or you can solder them through the hole. Just be aware you might melt the plastic a hair. Oh, secure. Which is what I did here, so this solder joint was sticking, and that's why I couldn't get it to go through. So, this now functions. Screw it back together, and solder the wires back on. And while it's out, we'll put the grease on it. And I'll show you how I do it. More. Two more. So, there we go. Bumping it up to 4 volts on my bench, just so it spins a little faster and has a little bit more power. And I take my grease. Yours probably won't come in a handy little tear package like this. And I just stick it on the first gear. And because it's spinning, it will actually start sticking to all the gears on the same row. You can hear it probably just got a little quieter. I just put a little bit on each row of teeth. I don't know if you can hear it, but it's really quiet now. You can apply it with a paintbrush, You can apply it with a syringe. I just got a whole bunch of these blister packs from an electronics manufacturer who use it for electromechanical connections. That's why it conducts electricity. So this cannot be used across a circuit board. It is hydrophobic, so it does repel water. But at the same token, if you use it across these contacts, you'll short it together. So, but there we go. It's running. It's re-lubricated. I'm going to put a little grease on these flat gears here on the top, right on the edge, and knock the wire off. Use grease sparingly. Grease is a good lubricant, but at the same token, it also causes dirt to stick to it. Put a dab of grease on all these other gears that I've already cleaned off. So that way, as they spin, they'll lubricate as well. You know what? I know the music box was okay, but I'm just going to put a little bit on the worm gear, which will go into the other gears, and there we go. Like that. I usually use a silicone-based grease or a lithium grease, depending on what I'm doing. If it's a high torque motor, I'll use the thicker lithium grease, or silicone grease, sorry, because it can overcome the resistance caused by the grease. Like this. I'm only running this at just under half power. So there's a lot of power. But there has to be, because it's turning a lot of mass. So you need to have all that power to overcome that mass. So let's solder the wires and reassemble this thing. And then test it out. And then if it works, then I will be at 2 for 4 for these Enescos so far. Assembly is just the opposite of the disassembly. I'm sure you're not going to want to see it all. I'm also going to service and refine the missing screw for these axles. I'll clean out some of this grease real quick before I forget. So when I stick it back in here, it'll have the fresh grease. Get rid of that broken gear. There we go. Pressed on the other side, and there's a little bit of a gap. I can put my spudger in there, like so. So that way it's not rubbing against the plastic. So there's a small enough gap to prevent any overload of friction. This whole shaft moves. You don't want to pinch it so tight that you're causing friction from the clamping force. Alright, I'm going to go ahead and get this all repaired, put back together, and then we're going to give it a test. To save on time on the video, I'm just going to pause it. You've seen me solder and reassemble screws a few times if you watch previous videos, and that's usually why these videos get so long. It's all the time in disassembly and reassembly. And I'm trying to cut back on the length of the time. But each piece is slightly different than the piece before it. And I'm trying to show you the proper way to get into it and do the work. Get all that nasty brown grease out. So. Anyhow, return in just a few moments with the hopefully completed and functional Mickey Snow Patrol, I believe is what it was called. Now I have the box right next to me and I can't read it. Mickey Mountain Patrol. Sorry. Whew. So anyway, I'm putting some flux on there to give it a better cohesion, since the original solder that's on here is horrible and I can't get it to remelt. So we're going to use some flux. Anyhow, shall return with a hopefully fully functional and assembled Snow Patrol. Be back in a moment. Alright, it's back together. I glued Minnie back on. So she's glued back to her seat. As you can hear, it's going. So we got the moving radar. Mickey is pivoting back and forth. Goofy is doing the ski lift. Donald's going around outrunning the spinning snowball. So, and then of course Minnie is going around the ski lift. I've had it running for about 3 minutes now. As you can see, it's good to go. So the reason that she was having issues, the owner, with it not turning or turning intermittently, was it had broken gears. The big culprit would be that 10-tooth, because the 10-tooth wasn't pressed onto the knurling anymore because it split. The other 2 gears, only part of the gear was broken, so it still had enough bite from the fatter base gear to keep it spinning. So, but it's now been running for, I don't know, 3 minutes or so. Get to hear the same MIDI music over and over and over again. So we'll take off these pieces, put it back in the baggie, set it back in the box, wrap up the power cord, and it'll be good to go back to its owner. So hopefully this helps you with your Enesco or something similar as far as how to take it apart. If you have a tight gear that won't come off, try and pry it up carefully from underneath. The gear I was thinking would come apart wasn't the right gear, it was the opposite side of the gearbox, which was surprising. But I just put pressure on both sides until the shaft started moving, and once it started moving, I could see which side it was sliding. So, other than that, there you go. There is Mickey's Mountain Patrol, fully functional, back together, cleaned and re-greased. Thanks for watching.